Pre-calculus, chapter 4, lesson 3. We want to go back and revisit something we talked a little bit about in lesson 1, and that is angles in standard position. We looked at standard position as an angle on the circle who has one side is the positive x-axis, and then we rotate this side around, and wherever we stop, the angle measured from the initial side, white on yellow doesn't look too good, that's theta. Remember, theta is the variable that we use for an angle measure. So we have these angles that we can determine by this rotation of this side. This is called the terminal side. This is the initial side. The vertex is at the origin. This is called a central angle. And you remember we discussed that when you rotate the arm of the terminal side counterclockwise, that will be a positive angle, and when you rotate the arm of the terminal side in a clockwise manner, that would be negative. Okay, let me say that again because I think I may have said it wrong. If we go counterclockwise, that is positive, and if we go clockwise, that is a negative. And again, it's always measured from the initial side, which is the positive x-axis. You remember that if we go half a circle, that is 180 degrees in degrees, or it is pi if we're talking radians. If we go more than that, then we're looking at obviously more than 180 degrees. And again, because I went positive or went clockwise, that is a negative angle. This would be negative 180. Okay, so having done that, what we want to talk about in this lesson are what we call coterminal angles, or angles that have the same terminal side. And the interesting thing about this, and it's going to be very important in our discussion later in periodic functions, is that this is a circle. And what happens when you go around in a circle? Well, you always end up back where you started. So, oops, I don't want to move that. You end up back where you started. So if I go to here, let's say, and the measure of theta in this case is, let's say, 60 degrees. If I rotate an additional one time around the circle, I end up exactly back in the same place that I started. So this would be a coterminal angle, or what would be the coterminal angle. The terminal side is in the exact same position, so it's 60 degrees, but we went once more around the circle. So because I went once more around the circle, to determine a coterminal angle, I simply add an additional 360 degrees to the original angle. So this would be a 60-degree angle. What would be an angle that's coterminal with that would be 60 plus another 360, which would be 420. So a 420-degree angle is coterminal with a 60-degree angle. And then, interesting enough, again, because it's a circle and periodic, if I went around an additional 360 times, so if I added an additional 360 to this, I would have another coterminal angle. So 780 degrees is also coterminal with 60. And actually, I could do this in an infinite number of times, because every time I go around the circle, an additional 360 degrees, I have an angle that's coterminal. And if I rotated a negative direction, so let's take a look at that. Let's say I have a 60-degree angle, and I want a coterminal angle, but I want it to be negative. So what I need to do is simply rotate in a clockwise manner, and I'm going to subtract 360 from that, because 360 is once around the circle. That's going to give me a negative 300-degree angle. So if I were to begin at the initial side here and rotate in an opposite way 300 degrees, I would end up with a coterminal angle. This angle here, excuse me, this angle here would be a negative 300-degree angle, and it is coterminal with a 60-degree angle. And then again, if I wanted another negative one, I would simply subtract another 360 degrees. So negative 660 would also be coterminal. So if I, again, started at 60 and I went around one time and then went around another time and stopped here, that would be a negative 660 degrees. That also would be coterminal with a 60-degree angle. So to determine coterminal angles, if I want a positive coterminal angle, I simply add 360 degrees as many times as it takes me to get a positive value for an angle. If I want a negative coterminal angle, I simply subtract 300 degrees as many times as I need in order to give me a coterminal angle. And again, that's if we're talking about degrees. Now, when you're talking about radians, okay, so let's say this is a pi over 3 angle. What would be a coterminal angle in radians? Well, you remember that once around the circle is 2 pi radians. So if I wanted a coterminal angle with pi over 3, I would have to add 2 pi to that. Okay, and here, because I have fractions, I'll need to get common denominators. So 2 pi over 3 is the same as 2 pi is the same as 6 pi over 3. So coterminal with that would be 7 pi over 3. And again, if I wanted another coterminal angle in radians, I would add another 2 pi to that, or another 6 pi over 3 to that. So 13 pi over 3 would be coterminal with this. Again, pi over 3 would be from here to here, and then coterminal would be here, and then once more around the circle, that would be 7 pi over 3. Another time around the circle would be 13 pi over 3. And again, I could continue to do that as many times as I wanted because it's periodic. It continues to come back to the same place. And again, if I wanted to go in the negative direction, I would subtract 2 pi. So if I had pi over 3 and I wanted a negative angle, I would subtract 2 pi. So again, changing that to a common denominator of 6 pi over 3. So the angle negative 5 pi over 3 is, sorry about that writing, is also coterminal with this. So again, negative 5 pi over 3 would be an angle that starts here and goes here. That would be negative 5 pi over 3. Okay, so again, coterminal angles are simply angles that have the same side as their terminal side, and to determine a coterminal angle, you simply add 360 degrees if you're in degrees, or you add 2 pi radians if you're in radian measure. If you're sketching these, and you will be asked to sketch, you want to kind of sketch it what I want, how we said it here. Let's say I asked you to sketch a 3 pi over 4 angle. Okay, well, pi over 4, you remember, is a 45-degree angle, and this numerator means that there's 3 of them. So if I count 3 45-degree angles, so one would be here, that's 45, another 45 would be 90, and another 45 would be 3 pi. So you'll want to draw the terminal side, and then starting from the initial side, you'll want to make a little arrow and then label it. This is how you'll want to sketch or to draw a angle on the coordinate grid if it asks you to do that. Okay, if I wanted you to do negative 3 pi over 4, then again you're going in the negative direction, so that would be here. You'll need to go this to indicate that it's negative direction, and then you have negative 3 pi over 4. So that will wrap up our discussion of coterminal angles. In the next lesson we'll look at determining the sine and cosine of these different angles.